Hopefully, yeah, I know, same outfit, you'll get over it. Hopefully, this section will go faster than the last section because this section doesn't have too terribly much in it, and most of what we're doing is talking about what we're seeing instead of doing so much calculating and going over old material that you should already have memorized, etc., from algebra stuff. So, in this section, we're talking about similar polynomials. And there are some things you need to make sure you understand. Like the symbol for similar is just the top of that congruent symbol. It's just a little squiggly. That means similar. So we know polynomials are similar if corresponding angles are congruent and, it's an important and corresponding sides are proportional. For example, let's look on page 272 at example number 1 that I can talk about it. So I'm looking in my book, you look in yours. Okay, 272, example number 1. At the top, they want to know if these are going to be similar or not. For A, we can see that angle C and angle F are all right angles, so they are similar. I mean, they are congruent. We can see that angle A and angle D are both x, so they are congruent. And since we have two congruent angles, we know the other angle must be congruent because all angles have to add up to 180. If we subtract the x and the 90 from 180, we get some number, which is going to be the exact same number as we get on the bottom. So all of our angles are congruent. Part 1, done. Now, the sides have to be proportional as well. So that means, back to a little bit of writing, for A, that CA, whatever CA is, over, that CA is my small figure, over the corresponding side of my large figure, which is FD. Is that an F or an E? FD. Would have to equal CB over FE, would have to equal BA over ED. So I first go ahead and, at least in my mind, kind of set up my proportions. I try to keep the small figure on top and the big figure on the bottom. Your book does the first figure you see and then the second figure you see. It's what they do. I don't know. Doesn't matter, like I explained in the last section, doesn't matter which one you go by. What matters is that your proportions end up being the same. So for CA and FD, we get 6 over 9. And that has to equal CB over FE, which is 8 over 12. And that has to equal 10 over 15. And if I were to reduce all of these, here I get 2 over 3, 2 over 3, and 2 over 3. So yes, my sides are proportional because I get the same fraction all the way across. That's what shows you that the sides are proportional. So if I were to ask for algebraic proof, that's the kind of thing that I'm looking for, that you show proof that all the numbers are proportional. Now, it doesn't say that we have to show proof, but I needed to show you how to do it so you know how to do it. This one doesn't say that we have to show proof, so we could just look at our numbers and say, oh, that's 2 over 3, that one will go down to 2 over 3, and that one will go down to 2 over 3, so we're good. Everything's good. This magic 2 over 3 thing is called the scale factor. It has to be true because each ratio in a proportion has to reduce down to the exact same fraction, and that fraction is called the scale factor. So for this particular similarity between these two polygons, which happen to be triangles in this case, the scale factor is 2 to 3. Now, if you and I would have instead put the big triangle on top of the little triangle, then our scale factor would have been 3 to 2. But they all would have come up as 3 over 2 because we'd be putting all of our bottom numbers on top and all of our top numbers on the bottom. Still corresponding sides, it still works. Your scale factor may be off depending upon how the book does it. That's why I said I always do small on top, big on bottom. That's what I always do. I got a big bottom, what can I say? However, your book, from what I can tell, tends to go with the first figure, whether it's big or little, over the second figure that you see. So for B, if you look at it, because we don't have to do this for B, you'll see what I'm talking about. You can tell that angle K and angle Y are congruent, angle L and angle Z are congruent, angle M and angle W are congruent, angle J and angle X are congruent. That's good. You can tell that the scale factor between KL and YZ is probably 2 to 1. We don't know that that's the case because they didn't tell us what those two lines were, but let's just say that it's 2 to 1. But the scale factor between LM and ZW has to be 1 to 1. We know that that one has to be 1 to 1 because it's one of the exact same line on top as the exact same line on the bottom because they're congruent. So since that is 1 to 1 and they are not all 1 to 1 going around, that means that they are not similar polygons because they don't have that same scale factor going. So that one takes care of B. It's a big old no. And all they say for their reason is that the sides are not in proportion. But I need you to understand there's a 1 to 1 ratio for the sides and not a 1 to 1 ratio for the tops and the bottoms. Now, we need to talk about C because I need to explain some algebra to you just to make sure you remember. So, we're going to do the same thing for C that we did for A, where you look at the triangles and the angles in the triangles, and you can see that they both have right angles, so that's all good. They both have 30 degrees, so that's all good, which means the other one must be 60 degrees, so that's all good. Our angles are taken care of. Good job. But when we go to figure out our sides, I want to talk about small triangle on top, the side that is RO. Has to be proportional with the side that is IG. I know that because they go from the same angles. So R was my right angle, O was my 30 degrees, I was my right angle, G was my 30 degrees. And that really is 4 square roots of 3 over 15. Moving on. Going from my hypotenuses, OS is the same thing as GH. OS, they tell me, is 8. GH is 8 square roots of 3. And then the other side is SR and HI. And they say that SR is 4 and HI is 4 square roots of 3. that really a 15? No, it's a 12. You should have said something. How rude. Can't believe you stayed so quiet during all that. Okay. So I'm supposed to be able to reduce all of these down. And this is where I wanted to make sure you had the math. Let me get on that so I don't have so much of an issue. This is where I wanted to make sure you had the math because I was concerned about your math and the whole rationalizing stuff, and I wanted to make sure you had it down before I just assumed that you did. Because in a couple of sections, they're going to be assuming a lot about you knowing about rationalizing. So when I have 4 square roots of 3 over 12, since the 4 is multiplied by the square root of 3, I can just reduce the 4 and the 12. Which gives me 1 square roots of 3 over 3. And I don't need to write the 1, so I can just get the square root of 3 over 3. That's good. It's rationalized and everything. We got the square root on the top, so there's no problem. Problem is you can't have a square root on the bottom. And you see I have a square root on the bottom here. Can't have that. We can go ahead and reduce our 8s down. So when I reduce my 8s down, that gives me 1 over the square root of 3. But then I have to rationalize 1 over the square root of 3. And I do that by multiplying by the square root of 3 on top and the square root of 3 on the bottom. So that's going to give me the square root of 3 on top. And the square root of 3 times the square root of 3 is the square root of 9. And the square root of 9 is 3. So we really do get square root of 3 over 3. And there's no need to stress over that stuff in the middle. Just that we end up with this. That's what matters. They all end up the same. For this one, the same thing is going to happen. You're going to cancel out the 4s, and you get 1 over the square root of 3. You multiply both of them by the square root of 3, and you're still going to end up with the square root of 3 over 3. You think I wasn't right-handed, but anyways, okay. It's over and done with. Rationalizing the denominator whenever there's a square root in the denominator is something I need for you to remember from Algebra 1. So if you don't remember it, you need some more practice on it, I can make that happen. Just let me know. Okay. So that takes care of C. Since they were all proportional and all of our angles were congruent, those two polygons are similar. Make sure when you're writing your similar polygons that you are making the corresponding angles in the right spot. So for this one in particular, if I say the triangle ROS is similar to triangle, I need to make sure I match up my angles. So it would be IGH. If. What is this? So make sure you match up your angles, that your right angle matches with your right angle, your 30 degree matches with your 30 degrees, 60 with 60. And if there are more letters, you gotta make sure those match up too. Okay, there's that. Which brings us to problem number 20 on page 275. Hey, look, I wrote it down. So part of what I wanted to point out to you about problem number 20 is some refreshing stuff from before. So they told you that this was 40 degrees. I need for you to understand that even though it's not part of this problem, I need for you to remember that since this is 40 degrees, this is also going to be 40 degrees. They said that this one was Y, which means this one up here is going to be Y. And they didn't tell you what A was, but we know that A has to equal A. It's a reflexive property kind of thing. So just to kind of remind you the corresponding angles, etc., yada, yada. Just like linear angles over here, this one's going to be 140. Not that it matters, just throwing it out there. Okay, so you get kind of the idea. Nobody said that this side was equal to that side. But since these are parallel lines, which they didn't even say that, if I remember correctly. They just said that the figures were similar. So that tells me that since they both share a side and these figures are similar, that these two must be parallel lines, and therefore we've got some similarities set up. So 3/7 has to be equal to 4 over whatever the big one is. That's good, right? So 3, which is my little triangle, over 7, which is my big triangle, has to equal 4, which is my little triangle, over this whole section, which we don't know. So I'll call it X. Do some cross multiplying, because they said they were similar. That gives me 3x is equal to 28. Why doesn't that sound right? I can't fix it. They told me they were similar figures. So divide both sides by 3. X is equal to 9.3-ish. 3 repeating. I ain't liking that. Hold that thought. AB, AC, AD, BD is obviously. AE is, CE is. It says ABC and ADE, and similar sides have to be congruent. Okay. I'm doing all good. So this whole side must be 9 1/3, which is AE. And I'm going to leave it 9.3 repeating because that's what it is. I don't feel like making fractions. I mean, you could, but it's just more work. Over here, since this is 7 and this is 3, 7 minus 3 gives you 4. So BD must be 4. And then over here, 9.3 repeating minus 4 is going to give me 5.3 repeating for this one right here. I still don't like the 0.3 thing, but I did it right. Yep. I wish I could tell you the answers were in the back of the book for this one, but they're not. But I did it right. Sorry. So these are the answers to that, and that is how you do it. Make sure you set up your proportion correct, which is what I've checked 3 different times now, so I'm pretty sure it's right. I just don't like the 0.3 thing. I wish I had more nice round answers and not funky fractions. Just saying. Get some others. But I know it must get on yours, because I know you don't like them either. So, okay. Classwork and homework, because that's where we're at. Classwork numbers 3, 7, and 23. And in case you don't remember, these are always from the practice exercises, because that's what they give you answers to in the back. This is on page 271. Go have fun. Hey, look, only 2 problems of homework. Just throwing it out there. Okay, bye.